Hello, everyone, and welcome to the webinar of Artix. My name is Pascal Fries, and I will be guiding you today. So what will we be talking about today? The topic of this webinar is common pitfalls in GitOps workflows, and it's my special topic as I'm a consultant at Artix, dedicated specifically to GitOps, automation, Git, and cloud native, in cloud native topics in general. So before we get started, I would like to make one announcement to you, and that is, if you have any questions during the talk, please feel free to submit them to the questions section in the sidebar. I will try to keep an eye on the questions in the sidebar and answer them straight away if possible. If not, if I miss one of the questions, don't worry, I will come back at you at the end of the talk. We will have a lot of time in the end of the talk for additional questions and also for answering previous questions that I didn't find time to answer or that I missed because I didn't see them. All right, I'll be very happy to hear about any questions because I always think that talking to people can be so much more interactive if there are any questions, and if you have so that I see if you have interest in other topics that I maybe do not have on my slides. All right, so who am I? My name is, as I said, Pascal Fries. I work at Artix IT Consulting as an IT consultant. My primary fields of interest are container virtualization. I'm a certified Kubernetes application developer. Also, what I'm very interested in is CI/CD, so continuous integration, continuous deployment. My specialty in that is GitOps, so operating systems primarily by committing changes to Git instead of doing things yourself. And all of this goes under the big keyword, everything as code. So formulating everything that you're doing as code. And before we get started with the topic, as a short motivation, I would like to give you some insight in what a day in my life looks like. So, as for most people, I start my day with a nice cup of coffee, and from then on, I basically go through a very long loop of doing a lot of things that are related to one another. The first thing is during my day, I will try to build stuff primarily for our customers, but also stuff that's special to Artix infrastructure. So I build stuff in the cloud. While I also do some things on bare metal, the primary stuff that I do is in the cloud, as is cloud native. How do I do that? Well, I write stuff. So I like to operate things by formulating them as code and executing that code to do stuff for me. So actually what I'm doing is I'm writing scripts for automation. I'm writing Ansible code, Terraform code, Kubernetes code, and like to see how automation does things for me while I just say what I want. In doing so, I also collaborate with my colleagues. So as I said, most of this stuff happens as code, and if most of that stuff happens as code, I can commit these changes to our repositories and collaborate with colleagues by raising issues in Git, by submitting merge requests, by merging other merge requests, as you see on that picture here. And that happens with colleagues. It also happens with customers. So I'm also guiding customers in setting up workflows that setting up workflows that implement this mindset of GitOps. Okay, and what I'm doing right now is I'm telling you stuff about Git. I'm telling you stuff about GitOps, and all of that goes under the big words: infrastructure as code, everything as code, and Kubernetes. And in case you didn't know, Arctics are also part of the Cloud Native Computing Foundation's landscape. That means that we are officially a partner of the Cloud Native Computing Foundation. We are an official partner considering the Kubernetes consulting and also Kubernetes training. Okay, coming back to the topic of what I do, all of these things have one common denominator. And the common denominator of all of these things is everything I do has to do with code. So everything that I operate in the cloud, everything that I try to build in the cloud, every way that I collaborate with colleagues, all of this has to do in some way or another with code. So in that sense, everything that I do is code, or everything that I do is something as code. Now the question is, how do you stay organized with that? Staying organized is one of the big topics if you're doing a lot of things in parallel, and you don't want to miss something. You don't want to do one thing and then forget about it a week later or a month later. Say I built something in the cloud and I formulated all of this as code, but then 1 year later I want to make an update. Now, the fact that I formulated it as code means that I could look back at the code, but the question is, how do I find that? I have to organize all of this in some way. And to answer this question, in the mindset of DevOps, what you would do is you ask the people that deal with code on a day-to-day basis. So who's dealing with code on a day-to-day basis for, well, basically every time ever since they did their job? Well, it's developers. Let's ask the developers, how do you organize code? How do you keep in mind what your code actually what code you actually wrote? How do you keep up to date on the code that other people had, and how do you go from code to actually operating something? And the answer is, well, first of all, it depends on which developer you ask. But some developers will tell you your code should be written in some way that it's as declarative as possible. Because if your code is declarative instead of imperative, you will have code that tells you what you are doing and not how you're doing it. And if you have code that tells you what you're doing, it will be much easier later on to find out what it actually means, what you did. They will also tell you that if you're already going that way, if you're already going that route of writing down everything that you're doing, like formulating your programs as code, it might actually be smart to formulate your test environments as code as well, or formulate your environments in general as code as well. And the key word for that is infrastructure as code. And what they also will tell you is you shouldn't be doing everything by hand. And by that I mean, as soon as you're writing code, you will have to, as a developer, compile that code, or you will have to test that code. And doing these tests manually will be a burden of responsibility on your own shoulders, because then you will have to think about doing all tests, doing rolling out your code all by yourself. You will have to think about this all of the time. A much better way of doing that would be to say, well, let's just automate that. So automate processes that have to do with testing, automate processes that have to do with rolling out your code, automate processes that have to do with releasing your code to the public. And all of these three things wouldn't work if we wouldn't have some central central point where you actually store your code. So having declarative code is fine. Defining your infrastructure as code is a great idea. Rolling out your code on an automated basis makes a lot of sense. But for all of this to work, you will need to have a centralized storage where you actually can store the code and where you and your colleagues have the possibility to find that code, work on it, and collaborate in some way. And what's shown the most success in, well, ever since it exists, is version control in the sense of Git. So what you should do always, whenever you're writing code, is you should submit it to some kind of version control system. The reason is, well, as soon as we have a way of declaratively writing down what we want, as soon as we have a way to automatically roll this out, it makes a lot of sense to keep a history of these things. Because then, if at some time something breaks, you can use your version control to roll back your code, which in turn describes your system, which then in turn can be automatically be rolled out to the real world. So let's say I defined some kind of infrastructure, and this infrastructure has some errors in them. Then I could, if I've submitted my infrastructure to version control, I could just roll back version control to an earlier stage. And in that earlier stage, I know that everything worked out fine, and an automated process will take care of rolling back the real world. So my infrastructure in the cloud, say, to that state that I describe in my version control system. And combining all of these aspects together now has come to this big buzzword that we call GitOps. So GitOps is an approach. This is just the approach that I described to you. GitOps means that as a developer, I'm writing code. And I don't mean as a developer in the sense of developing software, but as a developer in the sense that that I develop code that describes infrastructure, or that describes the configuration of some applications, or that describes which applications I actually want to roll out. So all of this I just write down as code. I will submit it to Git, and then some kind of automated process will take care of applying this stuff to the real world, of rolling out my infrastructure in the cloud, of provisioning servers, of provisioning networks, of rolling out applications. And the baseline of all of this is that we say we use Git as the single source of truth. So we're using Git as the centralized storage for where we want our information to be. I myself am just pushing information into Git, and some kind of and some automated process will take information out of Git and applying it to the cloud. And how does that happen? Well, we will have to find some automated process that does this for us. And luckily, there are many of these processes out there. In particular, for Kubernetes, there's two automated tools that are called Argo CD and Flux CD. Generally, you will call this automation process a GitOps operator or a GitOps agent, because it does the GitOps automated process for you. And you just have to take care of Git. But also, you could have these things much more general, not just applying to Kubernetes, by using some general continuous deployment tool, such as the GitLab CI pipelines, or Jenkins CI. Which one you choose will depend on where you want to actually deploy your stuff, and it also depends on your workflow. And this is what I do with customers. So usually at Artix, what I'm doing is I'm consulting customers in how to set up such a GitOps procedure. And of course, there's many questions in that case. And the biggest questions are, how do I manage credentials and other sensitive data? Because when I have to commit everything to Git in order for it to be rolled out to the cloud, I will have to think about how do I manage stuff that not everyone should be able to read, because Git is a big chunk of memory that allows to roll back to every instance in time. And so this might be actually a security problem, deploying secrets or committing secrets to your Git repository. How do I manage roles and responsibilities? Because in classical IT, you could just assign a role to somebody and say, okay, this person can do that, or this person can do that to some system in some cluster, in whatever. This doesn't work in GitOps that way, because in GitOps, everyone is just committing to Git, and then some operator actually does things. So the question is not who can do something, but rather who can submit what. The question is, of course, how do I manage that? How do I control who has access to which repositories, or how do I control who can submit what to Git? And the last question is, how do I manage release cycles? How do I deal with multiple environments? Because when working with Git, there's always this concept of branches, and the question might be, how do I actually implement that in a productive way? And these questions are not easy to answer, and they are the main pitfalls that you might fall into when trying to implement a GitOps workflow. And this webinar will be about how to actually answer these questions. So let's start off with, how do we deal with sensitive data? So something that you should not do is depicted on this slide. So what you should not do is write some password just into a plain text file, add the text file to your staging area, commit it, and then push it to the repository. Because in that moment where you commit some password to Git, it's always going to be there. Git will never forget. Git never forgets. Whenever you submit something to Git, it's there. You could roll back your Git repository to a state where where your password is not submitted, but the data itself will still be somewhere in the revision history of Git. You cannot get passwords out of there. So the solution is, please never do this. Never, ever, ever, ever commit unencrypted secrets. And what's on this slide is, and one particular important word on this slide is, never commit unencrypted secrets. It's completely fine to commit something that is encrypted, but never commit unencrypted secrets to your version control system. So what should you do instead? Well, there's two solutions. First solution is, if you should not commit unencrypted secrets to your version control system, well, you might actually not commit any secrets at all to your version control. So you might use some different tool for secret management, like a vault. Say I have some passwords that I want to share in my infrastructure, but I also want to operate my infrastructure primarily through Git. What I would then do is, well, there's not much room what I could do. Either I find some way in which I could put these secrets into Git, but without anyone else having the possibility to access them, or to just say, well, I'll operate my infrastructure through Git, but passwords are going another route. So passwords are managed externally. Every application that I'm using will have to ask for these passwords on demand. So I will not put secrets into version control. Instead, my secrets will have an individual management cycle. So someone else will be responsible, but at least some other tool will be responsible. An example for that is a vault. That could be an Ansible vault. It could be a HashiCorp vault. It could also be something much, much simpler, and we'll see that in the demo later. You could, of course, just use some storage, some external storage which supplies passwords to your pipelines and then rolls them out individually. If you're doing so, however, you need to reevaluate your existing deployments, because usually when you make a deployment, you are in the mindset that you can just supply passwords to whatever you're doing at the moment where you roll it out. And that won't work if your secrets are managed externally, because the moment that you roll out stuff, you don't roll it out yourself, but rather a GitOps operator will roll it out for you. So using external secret management is a great idea if you already have external secret management, but it can provide some kind of overhead, because you will have to reevaluate existing deployments if you haven't been using external secrets before. And the other choice is going back to the slide with the big never, ever, ever, ever. There's one caveat about this. So I said you should never, ever commit unencrypted secrets to Git. But what you could do, of course, is you could commit encrypted secrets to Git. So what do I mean by this? Well, you could just encrypt whatever your passwords are before committing them to Git. Then they are also in version control, so you have the chance of rolling back at any time that you want. And then when the deployment is actually happening, these secrets will have to be decrypted by the operator or in the target system. So then your cycle for committing to Git will basically be, before I commit, I encrypt everything that's sensitive data. And during the deployment process, everything will have to be decrypted. And how do you do that? Well, the decryption can happen at two places. Either the operator itself does the decryption process. So usually how these operators work is they clone your Git repository, they check out what has to be done, and then they do it. And during checking out what has to be done, they could actually decrypt your secrets if the operator is supplied with a private key for decrypting the secrets. Another possibility is to actually have the operator itself also be agnostic about the content of the secrets. So the operator will just push whatever encrypted stuff it finds to the target system, and the target system itself will take care of decrypting this. Both of them are valid options, and it depends on your workflow, what you want to do. Okay, let's move on to how do we manage access and privileges in GitOps workflows. As I said, in classical IT, you have the possibility of telling people or assigning privileges directly to users. So I could say, well, my colleague can administrate server A. I can't do that directly if all I have is Git, because if all I have is Git, well, the GitOps operator will be responsible for actually doing the administrative work. My colleague will only be able to push to some repository, and then Git will take care of the rest, or GitOps will take care of the rest. And what could happen in that case is, well, my colleague could go ahead and check out some main branch, like the branch that will be deployed to the productive system, could remove some common files, commit that stuff, and then push. That would be a very bad idea, because you should never work directly on a productive system if you have the chance first of testing your changes first. But how do we avoid this, since all people are generally equal before Git? Git doesn't know about anything of that. Well, the answer is, usually you're not just working with Git, but you're working with a Git remote. And access and the control of access and privileges actually is powered by your Git remote. So the question is, how would you structure your repositories that you can actually harness the powers of your Git remote in order to manage privileges and access for different teams? And again, there's different possibilities that you could choose. And the simplest one, arguably, is the monorepo. So we have one big repository, Like everything, all our infrastructure, all applications that we have are put in one repository. For example, let's say at Artix we will be managing a website, we will be managing another website, so the website of Artix itself, the website of Orcarino. Also, we're managing the configuration of our GitLab runners, and we're managing some monitoring configuration. Let's say we put all of that in one repository. This one repository will have two branches, one for testing purposes and for developing, and one that actually carries the productive infrastructure. Now, what kind of control mechanisms do we have? Well, since there's two branches, we could say, well, the productive branch, the main branch, this can only be changed via pull requests. Why would we do that? Well, because pull requests can be reviewed before they are merged. And we can assign the privileges to actually merge something to administrators. That's a very, very simple control mechanism. When should you do that? Well, you can use this for smaller projects. The primary reason why you would use that for a smaller project is, well, pull requests can be merged by admins. And that means that these administrators will be responsible for everything that's in that repository. So if you have one big repository, you will have one big chunk of responsibilities that your administrators will have to take care about. An advantage of that is that you have a very flat hierarchy. So you have one group of people that's responsible for merging, and you have one group of people that's responsible for committing changes to the development branch, where tests can be made, and then they just ask the administrators to actually roll this out to the real world by submitting a pull request. However, if you're dealing with a large project, of course, such a monorepo where you have everything in one repository puts much too large a burden onto your administrators. So if you have very large projects, what you could do instead is you could split the repository in many repositories. So we have like one repository that's responsible for the infrastructure that has to do something we have one repository that has to do with infrastructure. So it will hold the configuration of the runners, it will hold the configuration of monitoring. Then we have another repository that has only to do with the websites. And the great thing about that is now we have two repositories, and then we can assign different people different roles in these repositories. So basically what we're doing is having one repository per team, and then we can distribute the responsibilities much more fine-grained. Every team now can have their own admins, because we can have, for every of these repositories, we can have one group of people that are responsible for merging to the productive state. Okay, and lastly, how do we deal with multiple environments themselves? How do we manage a setup where we have a testing environment, where we have a productive environment, where we maybe have a development environment? And as I said before, this is done through branches. So in the ideal world, you will have multiple branches carrying multiple environments, and then people can just go ahead and merge from say the development branch to the main branch, and by that rolling out to the productive environment. And this has been known for a very long time. That we should use branches is a very old theme. You will also find it in the Bible. This is a quote by Moses, where he said, "The 3 branches are 3 days," and you will find it in Genesis. Okay, so how does this actually work? Well, as I said, you have to use branches for this to work. However, so you have to use branches so that people can actually work on, say, some mainline and then merge to some deployment branch, and from the deployment branch to a staging branch, and then from that staging branch to a prod branch, where all of these branches that are marked lightly blue are actually rolled out to the cloud. So there's one big problem with that. And the big problem with that is, well, some of that code will be specific to your environment. Say your configuration includes some address that you will have to open up in a browser in order to be able to access your environment. Then that will be different for every environment. And what happens from time to time is that people then say, okay, we have to use branches, and each of these branches represents one environment. So why not just put something else in every branch? Please don't do that. So please don't create a repository where you have one branch, where you have several environments, each of that environment corresponding to one branch, and these branches being completely different. It just doesn't make sense. If that's what you're doing, then you could use different repositories directly, because what you will never be able to do in that way is you will never be able to merge the branches, and that's the whole point of doing of using different branches. You have to use branches in a way that you can actually merge them. Let me show you how you can do that. So instead of having a different repository layout for every of the branches, use the same repository layout for all of the branches. So say you have one repository, and in this one repository, you have a base directory. This contains the common configuration for all your environments. And then you have some other directories that contain specifications that correspond to other environments. Now, what's rolled out to the cloud now? Okay, the base repository, it's common to all environments. So this is rolled out to the testing environment in the test branch. It's rolled out to the productive environment in the prod branch. And the specific configurations are also rolled out, but only in the branch that they are actually relevant for. So the test environment will consist of the base directory in the test branch and the config test directory in the test branch, while the productive environment will consist of the base or common directory in the productive branch and the config prod directory in the productive branch. The reason why you would do that is because now you can do something very interesting. You can actually make some changes to the common configuration first in the test branch, roll this out to the testing environment, because right now the changes are only in the test branch. And when you're sure that everything is working, you merge all of that to the productive branch, and now the common changes will also be applied to the prod. And then they will be rolled out to productive. Okay, let me summarize. It's a very short summary. GitOps will solve a lot of your problems in IT operations, if not all. Well, okay, that might not be actually true. As we saw, there's many problems. Let's rephrase it and say GitOps will actually cause more. No, that doesn't work either. Okay, actual summary. When you're using GitOps, there's many questions that you will have to answer before you know what your actual workflow will be. However, while there might be no gold standard, there is an ideal workflow depending on your use case. And if you manage to find that ideal workflow, it will actually make sure that it's way easier for you to stay organized with all of the code that will run your infrastructure. And you can harness the powers of Git in the sense that you could use version control to roll back to any state of your infrastructure, to use version control to merge different kinds of configurations into one another and to be able to test before deploying to production. And with that, as I see there are no questions, I would like to proceed to the demo. And for the demo, I prepared a Git repository. As I said, one repository for a small project. And what this small project will be doing, it will be deploying a Kubernetes cluster for us, and will deploy some applications to the Kubernetes cluster for us. And we will be able to see how we can actually roll back, or how we can actually go through the cycle of creating merges from a test environment to a productive environment. And since none of this exists at the moment, I would like to just start the pipelines. So I'll start the pipelines ahead of time, and then I'll show you what they are actually doing. So let me first create a development environment. So this will be our testing environment. This is creating the environment right now. And let's do the same thing for the productive environment. I called it just main for the main branch of the repository. Okay, so now what is the pipeline actually doing? I said it will be creating a Kubernetes cluster. And by that, I mean it will be creating a Kubernetes cluster per environment. We will have one development cluster and one productive cluster. This is written in form of Terraform. So we use Terraform code. It's very, very little code, actually. Well, this is all we need for a cluster. It loads a module that deploys a Kubernetes cluster. The cluster will have a name depending on the branch. So this is how we actually specify branch-dependent repositories. And then, as soon as the cluster is ready, it will generate an Ansible inventory containing all the hosts that are in this cluster, and then run some specific playbook to configure the cluster for us, to deploy some applications to it. And from there on, we can actually operate the cluster just by committing new stuff to Git. Okay, now this is happening at the moment for both branches. Let's have a look at the pipelines. So the pipelines just checked our code, and the code looks okay, and they're now creating a plan of what they're actually doing. So we still have some time to discuss what the pipelines will do after that. Okay, so I just told you that for every environment we'll be having one Kubernetes cluster. And now let me show you what will be happening after that. So here's an Ansible playbook that will be run on every of these clusters. And what do? Is we bootstrap a GitOps operation. For that, we will have to install some binaries. We will have to install an ingress controller in Kubernetes. That's just for us to be able to see what we're actually doing. Then it will copy some manifests over, and these manifests will be applied to the cluster. That's all that's happening. So in the end, we're just bootstrapping a Kubernetes cluster and installing some stuff to get started. And from then on, an operator, a GitOps operator called Argo CD, will be installed inside the cluster, and this operator will take care of doing everything else. So Argo CD will then monitor exactly this repository and roll out all changes that we made. Okay, I think the plan should be done right now. Yes, so we can actually start the clusters. Clusters are running, or will be running. This step might take 5 minutes, so I can show you what we will roll out to the clusters in the end. Okay, as I said, Argo CD will be deployed to the clusters, and inside and for each of the clusters, this Argo CD will monitor 2 different directories. Basically, it will say Argo CD will fetch its own configuration. It will fetch its own configuration from these directories: apps development and apps main. This goes back to this very structure that I showed you in the slides. We have like some common configuration that happens in every environment. That's what's happening outside here. Like the clusters are identical. And we have some specific configuration that's specific to each of the environments. And what are these specific configurations? Well, let's have a look at the development environment. There will be a guestbook application deployed in the development environment, and this guestbook application will be taken out of the same repository. Source is the same repository as we're in right now, GitOps demo. And it's taken from a very specific path in this repository, namely the directory guestbook/dev. And it's taken from the branch dev. This is exactly what you have here. Like we're going to the development branch, taking the application as it is in the development branch and rolling it out to the development environment. And there's some common code, as I said. The common code is in a base directory, and you will find this base directory also in the guestbook directory. By the way, since I've been very careful of not committing any sensitive data to this repository, this repo is actually public. So you could visit it at the moment to follow what we're doing right now and to copy any of the code. You're free to do that. It's really, there's no sensitive information in that repository, even though we managed to deploy it to a cloud where, of course, we need credentials. And that's happening because the pipeline actually uses, because the pipeline itself actually uses these credentials and takes them from settings of the Git remote, as GitLab itself provides the possibility to submit credentials as CI/CD variables. So this repository, we have under settings, CI/CD, the possibility to add extra variables, which will not be included in the code itself, but rather they will be masked inside any of the masked in any of the logs. Okay, let's have a look. The pipeline says it's still running. You can see what it's doing. So right now, we're configuring containerd on the Kubernetes clusters. Okay, so as I said, in the moment that the clusters are bootstrapped, Argo CD will, in the development branch, monitor the apps dev directory where an application is that says, well, look in the guestbook directory. And there's a dev directory, and in there you have specific configuration. This specific configuration mainly means we have an ingress resource, which in the development branch will use Let's Encrypt staging for creating certificates. So it will create somewhat self-signed certificates. And it will also set the correct URL for the cluster. Because this URL for the cluster is, of course, depending on the environment that we're in. It's the GitOps demo dev at atix-training.de. Similarly, we'll have the same thing for the main environment. However, in the main environment, we'll be issuing productive Let's Encrypt certificates, so real certificates served by Let's Encrypt. We'll have a different cluster URL, and hopefully everything works out. And of course, there's common configuration, and this common configuration is in the main, in this base directory. And in the base directory, we will have the actual guestbook application. And the actual guestbook application consists of a front end and some Redis database to store stuff. Okay, let's go back to the pipeline and see how far we are. Okay, the cluster is bootstrapped. However, the worker nodes are still joining. We're almost there. Let me tell you a little bit more about how this actually works. And in order to see that, let's see how credentials enter the game. I just told you that we have credentials defined as CI/CD variables, and now you can. I'll show you how they are actually entered into the Terraform code. So Terraform has this nice property that you can declare variables. So you can declare what kind of variables Terraform will look for. And I'm saying I want some credentials because I will be deploying to the cloud. So there's a token for Hetzner Cloud, where the clusters will be. And there are some credentials for AWS, where the URLs will be generated. So where we have our DNS. And these variables will be set by the pipeline. And the way they are set is by saying, okay, Terraform itself will expect a variable hcloud token to be set. And that happens by setting the environment variable Terraform variable hcloud token, and so on. So Terraform will automatically discover these variables as we set them. It will be providing them to the code that we read, and then it will use that to actually access the cloud, deploy whatever we want to deploy, in that case, Kubernetes clusters, and we're ready to go. Okay, clusters should be bootstrapped now. Apply step has passed. It was successful. Let's have a look at our development environment first. So I told you things will be happening via Argo CD. So let's access Argo CD. And as I told you, there's self-signed certificates in the development environment. Let's go to the productive environment. So here, instead of dev, which is the development branch, we go to the main branch. And in the main branch, here we have wonderfully signed certificates. Certificate is valid, and it's issued by Let's Encrypt. Okay. Let's go on. Okay, there's some error in this project. Maybe we'll just have to refresh. And here we go. Okay, I was a little bit too quickly. Okay, so let's look at the development environment. In the development environment, we have an application that's called apps dev. When this apps dev is monitoring the apps dev directory. And here we see it actually deploys an application called the guestbook. Let's have a look at guestbook, the application. It's currently creating. So Argo CD noticed that there is something inside the guestbook directory, namely inside the guestbook/dev directory. And it's just started an environment, and it's issued an application for us. Here's all the containers that it deployed for us. Everything's working out of the box. Same thing for the productive environment. Maybe I should need to refresh over here. Yeah, I need to refresh. And the productive environment is syncing as well. Now, as this is currently rolling out, let's have a look at the development environment. Let's have a look at our front end of the guestbook application. Again, this certificate is self-signed because we're in the development environment. Everything's working as it should. And here's the guestbook application. We have a working guestbook application. And what this guestbook application is doing, I will be, let me just give you a short sketch of what this guestbook application is doing. I can write stuff to this guestbook application, and it will log this, it down over here. And I could write down stuff even more. And how is this working? Well, the guestbook application itself is stateless. So from this thing that we have, this is the front end. The front end itself has two containers, and these three containers, sorry, and all of these three containers are stateless. And these stateless containers are accessing a database. This database consists, again, of three containers. It's a highly available database. And the front end containers will actually, whenever I click submit, it will write my message to the database. And this is happening by accessing this Redis leader. And then the Redis followers over here, they will copy whatever the Redis leader has, because whenever I load this page, it will try to read previously written messages from the database. And these will be read from the followers. So if I refresh the page, what should be happening is, well, since I already wrote these messages to the Redis follower, Redis leader, the Redis followers should have copied these messages so that if I refresh the page, my application can read them from the Redis followers. But it doesn't work. So why does this not work? Well, something went wrong. And how did something go wrong? Well, let's have a look. Apparently, since we cannot read stuff from the followers, the first thing that we will have to look at are the followers themselves. Let's have a look at the logs of the followers. Oh, that doesn't look good. The followers are permanently trying to connect to their leader, but they're just not finding it. Unable to connect. Connecting, unable to connect. Connecting, unable to connect. Something's really not working. So somebody must have broken something. And worse yet, the same thing is actually happening in the productive environment. Looking at the productive environment, we see the same problem. Okay, so somebody made a big mistake. Let's use the powers of GitOps to find out who made the mistake and what did he do. So who did the last commit to the repository? It's me. Okay, so I committed to the repository, and in the main branch, so the productive branch, my last commit was that I merged something. So obviously I rolled out some broken state. Let's see who pushed the broken state to the development environment. Oh God, no, it's again me. I broke something. So the last commit that I did was called roll back to older version. What did I do? Well, let's see, where do we see rollback to older version? Here it is. It's in the guestbook application. And it's in the base directory. The base directory, as I said, is the directory that's actually shared between environments. So it makes a lot of sense that the error is in here. And here's a Redis follower deployment, exactly what's throwing the error right now. And it says roll back to older version. Okay, what could I have done wrong? Let's look at the history of this file. Ooh, I rolled back this version from version 3 to version 1, and for some reason that broke something. So, well, let's undo that. Let's not go all the way. Let's not go through version 3 because I must have had some reason for rolling back. Let's go through version 2. So let's go to the development environment because we want to test our fix first. Let's go to the guestbook directory, base, and edit this follower deployment. Edit. Okay, let's bump the version. Fix. that is version 2 v2. Let's commit that. Okay, now that I committed, it's in the repository. Let's have a look at our testing environment. This is here, dev in the URL. Let's refresh. Oh, okay, it noticed something changed. Somebody changed something, and now we're starting a rolling update over here. New pods are issued as they should, and let's have a look at their logs. Oh, it's working. Master replica sync finished with success. Okay, so apparently I fixed it. Let's test if I really fixed it by going to the test page. So this is GitOps demo dev. So this is the testing environment, the world. So okay, that worked previously. Let's see if it still works if I refresh. Oh, everything's fine. Okay, now that that's fine, now that that is fixed, I can go ahead and do the same thing in main. And the cool thing about GitOps is now that if I wasn't the administrator of this project, I could have checked this. I could have tested this first, as I did right now, and then just issue a merge request. Let's issue a merge request. So I'm creating a merge request. So here I'm putting some description of what I actually did. And I say I fixed my previous error that caused persistence to create a merge request. Now that we have a merge request, somebody else could first of all check if that makes sense. I could have written down in my description, check the testing environment first. It's now working. It's not working in the productive environment. You should merge this, please. And well, since I am administrator of this project, I can just immediately merge it. Merge in progress. It was merged by myself. And then Argo CD will pick up the changes and it will run the rolling update. And we can check if it actually works now by saying hello, productive world. And everything's working. All right. And with that, I'd like to conclude the demo. What I've shown you is how you could use this workflow to make changes in a setting where you have multiple environments, where you have testing and development. So in our case, testing and productive. In our case, they were called dev and main. These environments had individual configuration, but some common stuff as well. And you could merge actually the changes to the common stuff so that that you have control over testing changes first and then merging them to the actual real world. What I've also shown is that that if you have a Git remote that supports pipeline variables, that you have a very simple way of actually doing secret management. And what I've not really shown you is how do you actually manage access, because it's just me and myself. But I'm pretty sure that you see that this merge request could also have been merged by someone else who has higher privileges than I have, and so that I wouldn't be able to access the main branch of this repository, and someone else would have to supervise all merge requests that happen. Okay, and with that, I'd like to thank you for your attention and hope that there are any questions. There are currently none, but since we're exactly at 11 o'clock right now, maybe there are some questions. Okay, if there are no questions, then I'd like to thank you again for your attention and hope that you join us again in the next webinar. And have a nice day. Goodbye.